Have you ever thought about the following simple question? How comes that you can draw a line with a pencil? Like this. It turns out that this simple question is closely related to one of the most interesting recent developments in solid-state physics, which is that we are now able to study atomically thin materials. Okay, so why are atomically thin materials interesting? Well, let me explain this to you by the example of this vanilla ice cream. Delicious! Now, as you can see, this ice cream has got a chocolate coating. But we still call it a vanilla ice cream because it's filled with vanilla cream. Now imagine that we remove all the cream so that only the chocolate crust remains. Would you still call that a vanilla ice cream? Well, probably not. It turns out that something similar happens if you manage to thin down a material so that what remains is only a few atoms thick. The properties of this few atoms thick material can be very different from the so-called bulk material, that is, from the normally thick materials. The first few atom thick materials, which researchers have managed to fabricate, is called graphene. It comes from graphite, the material that you can find in every pencil. And it turns out that the same properties of graphite that allows you to draw a line, it also allows researchers to obtain atomically thin samples from it. Now, since the discovery of graphene, people have managed to find a couple of other materials that can be thinned down to just a few atom thickness. Okay, so why are these materials interesting? Well, it turns out that atomically thin materials can have some pretty awesome properties, which makes them suitable to use in many areas. For example, in flexible electronics, or even for tennis rackets. Now, I am studying the electronic properties of these materials. That means how electrons can move around in these atomically thin materials. And because these materials are so thin, one has to use quantum mechanics to describe the motion of the electrons. And quantum mechanics can be pretty weird, at least compared to our everyday experience. When I think of quantum mechanics, the picture that often comes to my mind is the painting by the surrealist Belgian painter René Magritte. These strict and somewhat boring-looking persons represent for me the mathematical machinery that's behind quantum mechanics. But if you look at the whole picture, what you see is really weird. Well, for instance, in everyday life, I usually walk upright, or maybe upside down. Now, if I was an electron, I would have much more possibilities. I could move forward like this, or maybe like this, or this. I am sure that a lot of interesting physics is going to come from atomically thin materials.